Okay, what if I told you that we could create a star, but in a jar of water? I know, it sounds like something straight out of science fiction, but it's a real mind-bending phenomenon. So for this explainer, we're diving deep into the incredible mystery of sonoluminescence.
So let's just start with the biggest, most central question here. How on earth can you create light using just sound waves in a simple beaker of water? It just doesn't seem like it should be possible, and that is exactly what we're going to break down.
All right, so the phenomenon is called sonoluminescence, and the setup is, well, it's deceptively simple. You take a tiny gas bubble, you trap it in water, and then you blast it with sound waves. That sound makes the bubble expand and then, whoosh, collapse violently. And right at the very instant of that collapse, flash, it lets out this burst of light. Sound quite literally turns into light. This whole effect is so incredible, generating this immense energy from just a single bubble, that it's earned this amazing nickname, a star in a jar. And, when you see the details of the light it produces, you'll get why that's really no exaggeration at all.
And just look at the precision here. This is not some random flicker. We are talking about flashes of light that last for picoseconds. That's a trillionth of a second. And it's not just any light. It's powerful ultraviolet light, and it's all perfectly timed, flashing in perfect lockstep with every single collapse of that tiny bubble. But that incredible precision and all that power, well, that created a huge puzzle for scientists. For decades, the exact how behind this effect remained a really profound scientific mystery.
So any theory that was going to crack this case had to explain a very specific set of clues, almost like a detective story. And the questions were tough. Why did the light look so incredibly hot? Why did you need a specific type of gas like a noble gas to make it work? How was the timing so unbelievably perfect? And maybe the biggest question of all, where was all this energy even coming from?
To give you a sense of the sheer violence we're talking about, just look at this number. This is the acceleration of the bubble's wall as it collapses. It is a gigantic, almost unimaginable force. I mean, that's a 1 with 14 zeros after it. This extreme acceleration is the key to, well, everything that comes next. And that finally brings us to the big breakthrough, a paper from 1999 that proposed this absolutely brilliant solution. The authors argued the answer wasn't really about heat, not directly anyway, but about electricity. This was the electric clue. So, the core idea here is a principle called the Flexoelectric effect. And really, the concept is pretty straightforward. It's basically what happens when you squeeze something unevenly. The bubble's collapse creates this enormous, non-uniform pressure in the water around it, and it's this uneven squeeze that generates a super powerful electric field. Okay, so how do we get from a collapsing bubble to an actual electric force field? Let's walk through it. First, that bubble wall collapses and decelerates just violently. This creates that extreme uneven pressure we talked about. Now, because water molecules are asymmetric, they actually line up in this pressure gradient, separating their positive and negative charges. And the result? A massively powerful electric field. We're talking up to 10 million volts per centimeter, just appears right at the bubble's surface. And what happens when you have an unbelievably strong electric field just sitting there? Well, you've set the stage for a spark. Or in this case, you've basically created a tiny lightning storm right there inside the water. But of course, there's a catch. An electric field, no matter how strong it is, can't really do anything in a non-conductive material like pure water unless there's some kind of loose charge to get things going. It needs what the paper calls lucky electrons to kick off the whole process. So, where in the world do they come from? And this is where the two big pieces of the puzzle, heat and electricity, finally come together. The paper explains that as the bubble collapses, the gas trapped inside gets compressed so much that it becomes incredibly hot, like thousands of degrees Kelvin. That superheated gas is the source of our lucky electron. And here's how it all builds into this incredible electron avalanche. First, you get the ignition. That super hot gas frees up the first few electrons. Second, that powerful electric field we made, it grabs those electrons and just slingshots them to incredible speeds. Third, these high-speed electrons slam into other molecules, knocking even more electrons free. This creates a chain reaction, a rapid, massive discharge of electricity. It is, literally, a microscopic lightning strike.
So, the really crucial part here is that this tiny lightning storm model doesn't just sound cool, right? It elegantly solves all of those original puzzles that had scientists scratching their heads for so long.
I mean, this theory just brilliantly solves the original mysteries. So why the noble gases? Well, because they are super easily excited by hot electrons, and that's what produces the light. What about that crazy hot-looking spectrum? Well, that's not the bubble's temperature. It's the effective temperature of the super accelerated electrons, which is way, way hotter. And the perfect timing? The flash can only happen at the exact moment when you have both peak heat and the peak electric field. They have to align perfectly. It all just fits.
You know, this whole process raises one last, really fascinating question. Why does this seem to work so well specifically in water? Well, as it turns out, water is pretty special. See, water's secret is its fundamental molecular shape. The H2O molecule is asymmetrical. It has this kind of lopsided structure. The oxygen atom tends to be a bit more negative, the hydrogen atom's a bit more positive. And it's this built-in asymmetry that allows all the molecules to line up under that pressure gradient, creating the charge separation that gives rise to that massive electric field in the first place. So the star in a jar isn't just about a violent collapse. It's really about the fundamental electrical nature of water itself, which only gets revealed under these extreme conditions. And it leaves us with one final question to think about. If all of this is happening inside a single tiny bubble, what other incredible secrets are hidden in just a simple drop of water?